Welcome to Maths for All. I'm Aisling Flynn. This is Trigonometry 1.4, the cosine rule. The cosine rule applies to all triangles. Okay, so some of what we've learned, Pythagoras' theorem and the ratio sine, cos, tan, only apply to right angle triangles, but the cosine rule applies to all types of triangles. Okay, and just a reminder of how we label triangles. Okay, and we can use whatever letters we wish really, but depending on your question, the angle of interest you might call A, well then the side opposite it is known as small a. Okay, and then if this was angle B, the side opposite it is small b, and the third angle we might call C, and the side opposite it is called small c. Okay, so the angle of interest usually we call angle A, and the opposite side is small a, and then we have the other two, B and C, and so on. This is a right angle triangle, but it still applies. So angle of interest, call it A, and the others can be called B and C. Alright, so here's the cosine rule. So if you're given this triangle ABC, then the length of side A squared, so that's this A squared, is equal to B squared plus C squared. So they're the other two sides, and it really doesn't matter which one you call B or which one you call C, minus 2BC, so that's all multiplied by cosine A, and cosine A will be the angle here at vertex A, the one that's opposite side A. Okay, so that's the most important part, just to match up the side in question, A squared, small a, with the angle opposite, large A, and get those in the correct place in your formula. Okay, and when do we use the cosine rule? If the triangle is not right angled, we cannot use Pythagoras' theorem, we cannot use the sine, cos or tan ratios, and if we don't have matching pairs, okay, like we would in the sine rule, then you need the cosine rule. So really, as you can see, it's not as straightforward as the sine rule. It would be our last option, but it always works. Where will you find the cosine rule? So you'll find it on page 16 of the Formula and Tables books. It's in the trigonometry pages. Trigonometry of a triangle, you'll find cosine rule here. A squared equals B squared plus C squared minus 2BC cosine A. Now let's put it to use. The first example here is to find the length of an unknown side. Okay, so the information given is, in the given triangle, AB equals 6, AC equals 8, and the angle BAC equals 48. Find BC, correct to the nearest integer. Okay, so the notation here, remember the two parallel lines means the length or the magnitude of B to C. So we're trying to find this side, B to C. All right, we're only given one angle, which is 48 degrees. Look at how this is described or named. We have an angle sign, and then it's B to A to C. So B is here, B to A to C. So the middle letter describes where the 48 degrees is. Okay, and because it's the only angle we have, even if the letters were shown differently in the diagram, for the purpose of our formula, it's the only angle we have, the angle of interest. This is angle A, and therefore the line BC is side A. Alright, so let's begin by writing out our cosine rule. A squared equals b squared plus c squared minus 2bc cosine A. And we do need to use the cosine rule because we have no other matching pair. We have 6 and we have 8, but we've no information about the other two angles. It's not a right angle triangle, so we can't use Pythagoras or the sine, cos or tan ratios. Alright, so the next step is to fill in all the information that you do have, and then hopefully we'll be able to solve for what we need. So A is what we need. A squared equals, now b squared plus c squared. Now it doesn't matter which one really that you call b or c, but according to where my angles are, b would be 8, so 8 squared, and c would be 6, so 6 squared minus 2 multiplied by 8 multiplied by 6 multiplied by cosine 48 degrees. Alright, so we have all the information except for A, so this is solvable. So you can take as many or as little steps to work through these calculations. Okay, now the term that's to be subtracted is 2 multiplied by 8 multiplied by 6 multiplied by cosine 48 degrees. Okay, you can do it all at once on your calculator, and what I get here is 64.24. Okay, I've rounded off to 2 decimal places. My final answer needs to be a whole number, says the nearest integer. So just try that last term there on your calculators. Make sure you get the same result as I just did. So if we add the first two terms there, we get 100 minus 64.24. So we get a squared equals, so 100 minus 64.24 is 35.76. Now that's a squared, so to get a, we'll get the square root of both sides. So get the square root of that, and I have 5.98, okay. And I round to 2 decimal places, and to give my answer to the nearest integer, I'll say a equals 6. Okay, so pause that, look back through it, and see can you replicate that answer. So in this example, we're asked to find an unknown angle. Find angle ABC in the given triangle. So let's first identify where that is. So angle A, here's A to B to C. So it's this angle here as indicated already. Alright, so this is the angle we want to find. Now let's go through our options. There is no indication that this is a right angle triangle, that there is a 90 degrees angle, so we cannot use Pythagoras, we cannot use sine, cos or tan ratios. Can we use the sine rule? So to use the sine rule we need 2 matching pairs. So this angle at B here goes with its opposite side, which is 5. We have the side 4, but we do not know the opposite angle. We have the side 6, but we know nothing about the opposite angle. So we don't have 2 matching pairs, so we cannot use the sine rule. Okay, and therefore very quickly we're led to the cosine rule as our last option. Okay, so I'm going to write it down first. You'll find this in your formula and tables books. Cosine A. And now we're going to label. Now this may cause, and often does, a little bit of confusion because the letters on your diagram may not necessarily suit the formula. Okay, so a little earlier I said that the angle of interest in your question should be called angle A. Okay, for the purpose of the formula. So what's currently marked B for the purpose of the formula should be a, so I'm changing that there. And therefore 5 becomes small a. Okay, and the other two sides, it doesn't matter which one is which. Let's say b is 4 and c is 6. Okay, so you can forget the labels provided at the beginning. You use what you need as appropriate for the formula. Okay, so now let's fill in the information that we do have and see can we solve for what we need. Alright, so a, the side opposite our angle of interest, is 5. The other two sides are 4 squared plus 6 squared minus 2 times 4 times 6 cosine a. So we don't know that angle, but we do know everything else, so it is solvable. Now it's a matter of working out the numbers. Alright, and again you can take as many or as little steps as you require to do this. So 4 squared is 16, 6 squared is minus 36. Now minus 2 times 4 times 6, so 2 4s are 8 and 8 6s are 48 cosine a. Alright, now what do we do next? Well, we're solving an equation, so we're going to try and isolate that cosine a. Alright, so that, and then that will allow us to find angle A. So a bit more calculation here. 16 plus 36 is 52 minus 48 cosine A. Right, so we're isolating the cosine A, so I'm going to move this 52 to the other side. We'll take 52 from both sides. Alright, 25 minus 52 gives me minus 27 on the left hand side, equals to minus 48 cosine A. The next step that you would always do, imagine if that cosine A is an x. If you had 3x, you'd always divide by whatever's beside it. Okay, so we're going to divide by minus 48 on both sides, because minus 48 divided by minus 48 is 1. So we get cosine A on the right hand side, and when you divide the minus 27 by the 48, or minus 48, I get 0.5625. Alright, so here we've reached an answer for the cosine of angle A. 0.5625. So I want you to think back to your working backwards lesson now. How do you find the measure of angle A if you know the answer for the cosine of angle A? Well, we're working backwards. We use the inverse function. So we will get the angle A if we get cosine inverse of 0.5625. Now recall how you get that on your calculator. You use the shift and the cosine button to select cosine to the minus 1, the inverse of cosine, and type in 0.5625, and you'll get the measure of angle A. So I get 55.77 to 2 decimal places degrees. It's not specified how accurate we need to be, so we'll leave it there. So 55.77 degrees. Okay, I want you to pause the video there, and I want you to see, can you replicate that answer, okay, with the correct labeling of the triangle and working through to get cosine A and then use the inverse function. So the best way to go about getting a handle on this is to practice. You do it now with your quiz and written exercises.